In this video, we'll compare Nginx and Pingora, a Rust framework for building network services. We'll measure latency using P99 percentile, which I think is one of the most important metrics for any proxy. Then throughput by counting how many requests per second each proxy can handle, and we'll measure availability of each proxy or the error rate. Finally, we'll measure saturation or how fully utilized the service is by measuring CPU usage, memory usage, as well as CPU usage of the applications behind these two proxies. I ran all my tests on AWS. For this test, I used large EC2 instances for proxies, each with 2 CPUs and 8 GB of memory, medium instances for the applications behind the proxies, and EKS cluster to deploy my monitoring components along with the clients to generate load. I used Nginx version 1.27.2 for this test and version 0.4.0 of the Pingora library to build a proxy. I configured Nginx to auto-set the number of workers based on the number of CPU cores. Given that large EC2 instances have 2 CPUs, Nginx creates 2 independent worker processes. I also set 4 threads per worker based on the previous tests. For the proxy configuration, I used upstream block with 4 backend applications and used the default round-robin algorithm. The important part is to enable keep alive along with the sending proxy connection header. I also enabled HTTP2 protocol and provided a self-sign certificate. Since Pingora does not have access logs out of the box, for a fair comparison, I disabled access logs in Nginx as well. Lastly, I added X-forwarded4 header with a real client IP address to be forwarded to the application behind it. Most high-level proxies like Caddy and Traffic do this by default, but with Nginx and Pingora, you need to have some knowledge and experience to make it efficient. Now, Pingora is a Rust library, so you need to have some knowledge of Rust. Keep in mind that Rust is not the easiest language to learn, but it allows you to build very efficient applications. For example, here I create a load balancer. You can refactor and use the same static file to configure your proxy as with Nginx. Then I implement active health checks for each backend service. Next, I provide a self-sign certificate and upgrade connections to HTTP2. There are different built-in functions in Pingora, and you can use upstream filter to add headers like X-forwarded4 along with other metadata. Alright, let's go ahead and run the test. It took around 1.5 hours to run, but I'll compress it into just a few minutes. On the left-hand side, you can see the number of requests per second each proxy receives from the clients. We slowly increase the load until both proxies fail. From the latency graph, you can notice that throughout the test, Pingora's latency is consistently lower than Nginx. At the start, when latencies are very low, it might seem insignificant, but consider if you have multiple microservices in a chain, each proxied by either Nginx or Pingora. If you have a long chain, perhaps 5 or even 10 microservices, the latency can quickly add up, especially as the load increases. On the right-hand side, we have CPU usage, which for some reason is initially higher for the Pingora proxy at the beginning of the test. But let's see what happens as we progress. Now, memory usage is also very similar, at least when both proxies handling a medium load. Keep in mind that many tools behave differently under heavy load and might fail for different reasons. If you use Nginx as a reverse proxy, make sure you enable keep alive on the upstream services. Otherwise, your latency and CPU usage will be higher. Take a look at these benchmarks without keep alive and compare them with this one. I've also included a PR in the description explaining how to fix it. On the other hand, Pingora does this automatically, but you can adjust the pool size, which I've set to be the same for both proxies. Finally, availability typically remains at 100% until both proxies start to degrade under heavy load. Up until 20,000 requests per second, both proxies handle load very well, with latency for both staying under 1 millisecond, which is excellent performance for any proxy. You can compare this with caddy or traffic in these benchmarks. At this point, Nginx has reached 40% CPU usage, and Pingora is around 70%. This is the moment when, if you need low latency, you would want to start scaling your proxies horizontally by adding more instances. After this point, both proxies begin to slow down, and latency increases for both. So this is the critical threshold. Soon after, at around 28,000 requests per second, some requests to Nginx start to fail. Either clients get a timeout with 408 status code, or internal error with 500 status is returned to the clients, which slightly decreases availability. If you look at the actual numbers, these are just a few failing requests out of thousands per second. At around 34,000 requests per second, it becomes clear that Nginx can no longer keep up with Pingora, and it becomes unstable and drops some requests. However, the latency for the Nginx stays relatively stable, just a bit higher than Pingora's. Let's continue the test until both proxies are unable to handle any more requests. You can notice that CPU usage starts to converge by the end, with Nginx also reaching full CPU utilization at around 40,000 requests per second. This is very consistent with the results from the previous Nginx versus traffic benchmark. So running benchmarks in NBS is a reliable way to measure performance differences between different tools. On the other hand, Pingora reached around 48,000 requests per second. As I mentioned, latency is the most critical metric as it directly affects user experience, while throughput impacts the infrastructure cost. Alright, let me open each graph for the entire test duration. First, we have a requests per second graph. You can see that Nginx reached around 41,000 requests per second, and Pingora around 48,000 requests per second. Next, we have latency. It's very consistent. Pingora maintained the lowest latency throughout the entire test, even at the end. Let's compare the latencies at the beginning of the test as well. You might think the difference is not significant, but it does matter. Then we have availability. You can see some degradation in the Nginx graph, but it stays around 99.99%, which is perfectly acceptable. Following that, we have CPU usage. Although Pingora used significantly more CPU at the start, I thought it would fail first, but CPU usage for both converged at roughly the same time, with Pingora ultimately achieving higher throughput. Next, we have memory usage, which usually is not an important factor in CPU-bound applications and performance tests. And finally, we have CPU usage for the applications behind these two proxies. You can see slightly higher CPU usage for the Nginx applications, but this only happened when Nginx started to fail at the end. Throughout the test, it remained at the same level. I also measured network usage for both proxies, which didn't fit on the screen. Typically, I measure more metrics that can fit in one screen. Now, if you have programming experience and looking for higher performance, Pingora is a way to go. Keep in mind though, it's a library you can use to build proxies. So if you find Nginx complicated, you'll have to essentially build your own Nginx using a Rust library. I would definitely consider including Pingora in my future production projects. I have other benchmarks that you might find interesting. Thank you for watching, and I'll see you in the next video.